Good afternoon, students. Today we are discussing paper 7. Paper 7. Paper 7. Black 3 heterocyclic compounds, unit 15. Paper 7. Black 3 heterocyclic compounds, unit 15. 3 and 4 membered heterocyclic compounds. 3 and 4 membered heterocyclic compounds. First, we are discussing how many compounds? Around 6 compounds are there. We are discussing one by one. Oxyranes. First one is oxyranes. Oxyranes means the saturated 3-membered heterocyclic compounds are saturated 3-membered oxygen containing heterocyclic compound is oxyrane. Saturated 3-membered oxygen containing heterocyclic compounds are called oxyranes. Now we are going to synthesis. Synthesis of oxyrane. Best method for synthesis of oxyrane is epoxidation. What is epoxidation? Epoxidation. When double bonds, when alkenes undergo epoxidation, when alkenes undergo epoxidation with hydrogen peroxide or paracids in presence of base, then epoxidation will be takes place. Epoxidation will be takes place. Epoxidation will be takes place. Okay. This is the best method, one of the method. Second method is beta hydroxy beta halohydrines. Next one is beta halohydrines from beta halohydrines. Beta alpha beta halohydrines. When beta halohydrines reacting with base abstract the proton from here, then oxygen need to charge, this need to charge attack it halogen attached carbon, and elimination of halogen takes place. X minus the product is epoxidation will be takes place. Epoxidation will be takes place. Next one is third one is from 1, to dihalos. From 1, to dihalos. When that 1, to dihalos, when 1, to dihalo, when 1, to dihalo, first reacting with 1 mole of tosyl chloride. When reacting with 1 mole of tosyl chloride, one of the hydroxy group undergo tosylation. One of the hydroxy group undergo tosylation. Tosyl group is very good leaving group. Therefore, oxygen lone pair of electrons on hydroxy group undergo attacking on tosyl attached carbon. Then epoxide will be formation takes place. So these are 3 methods for synthesis of the epoxides. And fourth method is from carbonyl compounds. Shallow substituted carbenes. From carbonyl compounds into shallow substituted carbenes. When carbonyl compounds reacting with halo substituted carbon anions, prints of lithium, then the product is the product will be formation. Mechanism for this reaction is when reacting with lithium, bromine is substituted by lithium, and lithium is a positive and here negative charge. This negative charge attack at carbonyl carbon. O minus CH2 Cl, CH2 Cl, here lithium plus. This will be attack at the halocarbon, and chlorine is elimination takes place, nothing but lithium chloride elimination takes place, then forms epoxide with here methyl, here phenyl is the product will be formation takes place. Next, from carbines, from carbene, fifth one, carbene, carbene insertion in carbonyl carbon, carbene insertion in carbonyl carbon, carbene insertion in carbonyl carbon. Isomethane then produces CH3 hydrogen. Epoxide will be formation takes place. Mechanism for this reaction is when carbene undergo homolytic cleavage in presence of sunlight, then produces diazomethane. Diazomethane undergo diazomethane when diazomethane reacting with carbonyl compounds, then produces epoxide the product. When diazomethane under sunlight, they produces carbene. This carbene is undergo insertion between carbonyl here. The bond is undergo insertion takes place, then produces CH3 hydrogen, oxygen, CH2. These are epoxide will be formation takes place. So next reactions. Next reactions. Reactions. When oxygen ring is oxygen is a three-membered ring, with the oxygen atom is present. In general, three-member rings are highly unstable. In this three-member ring, oxygen atom is there. This three-member ring containing oxygen having two lone pair of electrons are there. Therefore, this ring is highly unstable. When nucleophile attacking on the carbon atom, the ring readily opens, takes place. Okay, that opening of the reaction, opening of the oxygen ring in two ways. One is acidic catalyzed reaction. One is acid catalyzed reaction. Acid catalyzed reaction when oxygen reacting with acid medium. When oxygen reacting with acid medium, lone pair of electron oxygen attack it oxygen, then oxygen will bearing positive charge. This positive charge is highly unstable. In nucleophile attack at oxygen carbon, the bond is shifting towards positively charged oxygen side, then produces HOH. 1 comma 2 dials will be here. 1 comma 2 dials will be formation takes place here. Other than this hydroxy group, if you take any nucleophile, the nucleophile substituted product will be formation takes place. Next, reaction with organometals. Reaction with organometals. Reaction with organometals. When epoxides, oxygen reacting with methyl magnesium bromide halide, methyl magnesium halide, that negative charge attack at ring, that negative charge attack at ring, followed by hydrolysis, then OH, then CH3. Product will be formation takes place. Next, reduction with lithium aluminum hydride. Reduction with lithium aluminum hydride. Epoxides or oxidants are undergo reduction with lithium aluminum hydride. Opening of the ring takes place. Products are alcohols are the products. When it is a unsymmetrical, no problem. If it is it is a symmetrical, no problem. If unsymmetrical, if you take unsymmetrical, ring opening from sterically less substitution side. In case of unsymmetrical, the steric less crowding side will be open takes place. Then the product is OH. The product will be formation takes place. Next one is next photolytical reaction. Next photolytical reaction when oxygen reaction in presence of sunlight, then the two products will be formation takes place. So bond will be breakaging like this, double bond and oxygen will be product will be formation takes place. If it is like this, cleavage takes place, then the product is CH3 C double bond O H will be the product will be takes place. There is a two types of wavelength. This is a strong wavelength. This is a shorter wavelength. Shorter wavelength is a longer wavelength. Reaction B takes place. Next one is deoxidation. Deoxygenation reaction. Deoxygenation. deoxygenation reaction. When oxygen reacting with triphenyl phosphine, the product is CH2, then triphenyl phosphine C double bond O is the product will be formation takes place. That will be bond will be formation takes place. Next one is thyrenes. Next one is thyrenes. Thyrene is a three-membered ring with one oxygen atom, one sulfur atom. Thyrene is a saturated three-membered ring. Saturated three-membered ring with one sulfur atom. Saturated three-membered ring with one sulfur atom is a thyrenes. Now, next one, synthesis of thyrenes. Next, we are discussing synthesis of thyrenes from beta mercaptoethanol. From beta mercaptoethanol. From beta alpha beta mercaptoethanol. From beta mercaptoethanol. When this beta mercaptoethanol reacting with SOCl2, elimination of 2 moles of HCl, then the product is oxygen, sulfur, C double bond O. Okay, it is undergo elimination of carbon dioxide gas. Elimination of carbon dioxide gas, then produces thyrene is the product will be formation takes place. Next one is from 1,2-diols. From 1,2-diols. When 1,2-diols reacting with SOCl2, one SOCl2 మీకు ఇప్పుడు కావాలా So one cyclic compound will be formation takes place when the reacting with SCN minus, reaction with SCN minus, the negative charge will be attack at here. The negative charge on sulfur attack at ester oxygen, then the bond will be shifting to oxygen side, then sulfur Cn, then O, C double bond O minus will be there. Now it is involved in loss of carbon dioxide gas. Now it is involved in loss of carbon dioxide gas, then elimination of carbon dioxide gas, then the product is SCN O minus. It is attack at triple bond of cyano carbon, then sulfur, then here oxygen. Cn is the product negative charge. It is undergo opening of the ring, then loss of OCN minus, then the product is thyrene product will be formation takes place. Next one is from oxyrenes. From oxyrenes. From oxyrenes. From oxyrenes. Third one is from oxyrenes. When oxyrenes reacting with HCN, then here opening of the ring takes place. O minus HCN will be attacking takes place. In presence of base, then the product thyrene is the product will be formation takes place. Thyrene in the formation takes place. Next one is reactions. Thyrane ring relatively less stable than oxide. Thyrane are cleaved by electrophilic and nucleophilic reagent. Thyrane ring is less stable than oxide. They are readily cleaved by electrophilic and nucleophilic reagents. One is with electrophilic reagents. Electrophilic reagents. When thyrane thyranes reacting with HCl, thyranes reacting with HCl, H plus Cl minus. The H plus is attacking on sulfur, lone pair of electrons, and Cl minus attacking on sulfur attached to carbon. The bond shifting toward positive charged sulfur side, SH and Cl minus will be the product will be formation takes place. Next, reacting with nucleophilic reagents. Reaction with nucleophilic reagent. Lithium aluminum hydride. Opening of the ring takes place. Opening of the reaction takes place, and reacting with amines. Attacking it here. Less substitution side will be open takes place. Less substitution side will be open takes place. Reacting with ethanol. The product will be takes place. Desulfonylation. Desulfurization when sulfur thyranes reacting with PO, reacting with phosphonate, triethyl phosphonate, reacting with triethyl phosphonate. The sulfur atom of phosphorus will be open takes place. Then next one is oxidation. Oxidation. Thyrenes reacting with NiO4, reacting with sodium metaperidate. Sodium metaperidate. The oxygen atom is attacking on sulfur will be takes place. Ethylene sulfoxide. Ethylene sulfoxide will be takes place. This ethylene sulfoxide, when reacting with 100 degrees Celsius, alkene plus SO will be formation takes place. Next one is aziridines. Next one is aziridines. Next one is aziridines. aziridines. When a three-membered saturated three-membered nitrogen containing compounds are aziridine. Saturated three-membered nitrogen containing compounds are aziridines. Synthesis of these aziridines from Grabial rings closing. Ring Grabial ring closure. Grabial ring closure reaction. In this Grabial ring closure reaction, alpha halo alkylamines. Grabial rings closure. Grabial ring closure. When when alpha when beta halo alkylamine. Alpha beta beta halo ethyl amine. When beta haloethylamine reacting with base, reacting with base abstract the proton from here, then elimination of X, then that forms, there will be formation takes place. Next, second one is from alkenes and azides. From alkenes and azides. When alkenes reacting with azides undergo 1,3 dipolar addition reaction. 1,3 dipolar addition reaction. Then the product is N double bond R. 1,3 dipolar addition. This double bond undergo influence of thermal or photochemical condition, elimination of nitrogen gas, then forms aziridines are the product will be formation takes place from oxidants. When oxidants react with triphenyl phosphine iminophosphorins at 4 and 140 degrees Celsius, then elimination of triphenyl phosphine O plus our aziridines are the products. Aziridines are the products will be takes place. Next, Hoch-Kammler method. Hoch-Campbell method. Oximes with beta hydrogen reacting with Grignard reagent, then produces aziridines. Oximes oximes having beta hydrogen. Beta hydrogen. Oximes having beta hydrogens reacting with phenyl Grignard reagent. Grignard reagent. The Grignard reagent abstract the base from the beta hydrogen. Then negative charge. This negative charge attack at here oxygen atom and elimination of hydroxy group. Then the product is azerine is the product. Now this azerine when reacting with phenyl magnesium bromide, phenyl magnesium halide. This phenyl magnesium halide attack a double bond, the double bond shifting towards nitrogen side. Then R phenyl NH dialkyl. So this is the aziridine is the synthesis will be takes place.
Sir, paper is not clear, sir. Okay. No, okay, sir.
Next reactions of aziridines. Reactions of aziridines when so in general 3-member rings are highly unstable. Here more electronegative nitrogen atom is there. Therefore, this ring is more highly unstable. Therefore, when nucleophile attacking on carbon atom, the ring is opening towards nitrogen atom side. Nitrogen atom side. Simply, I am taken here. When we take HCl, lone pair of electrons on nitrogen donate to proton, then forms NH2 positive on nitrogen. The next step, chlorine attack and carbon atom, the sigma bond shifting towards nitrogen side, therefore NH2 and a beta halo amines will be formation takes place. So if you take alcohol or water, if you take water, OH will be takes place. If you take ethanol, NH2 OET is the product. Okay, like this ring open takes place will be here. Next substitution. Next one is aziridine NH reaction with aziridine NH. Reaction with aziridine NH. Reactions with aziridine NH. Aziridine NH function. Reaction with aziridine NH function. When aziridine NH reacting with NaOCl by loss of proton here, NaOH will be elimination and chlorination takes place on nitrogen. If we take base subtract the proton from here. When we take Syl chloride, that Syl will be takes place on nitrogen. Acylation will be takes place on nitrogen. So we will take if we take acrylonitrile, Michael addition takes place here. That base in presence of base, Michael addition takes place. Michael addition takes place like this. Different reactions are involved in aziridine NH. Next. Next one is rearrangement reactions. Next one is rearrangement reaction. When an acid aziridine undergoes distillation.
Sir, I have doubt, sir.
Ah,
Sir,
చెప్పండి. Tell me.
సార్ అది వినైల్ నైట్రైల్ సార్ ఎక్రైల్ నైట్రైల్ సార్ అది మీరు రాసిన పైన
Acrylonitrile.
ఎక్రైల్ మీన్స్ 3 కార్బన్స్ ఉంటాయి కదా సార్ CH3 CH డబుల్ వన్ CH వినైల్ నైట్రైల్ లాగా
This is
ఏంటి సార్
also
CH ఇంకో కార్బన్ ఎక్స్ట్రా ఉండదు సార్
this is acrylonitrile. This acrylonitrile.
వినైల్ నైట్రైల్ సార్
Then
వినైల్
after
నైట్రైల్
vinylnitrile also we are called two type. Okay.
ఓకే
Vinylnitrile also we are called.
ఓకే సార్
The distillation here, the bond shift here in the rearrangement, the sigma bond between carbon and nitrogen shifting towards nitrogen and carbonyl carbon, this pi bond shifting towards oxygen side and shifting to here. Then the product is N double bond Cr oxygen like this. Okay, the product is 1, 2, 3, 4, 5. I'm writing like this. Nitrogen double bond R O. This is the product will be formation takes place. 1, 2, 3, 4, 5. This is the product will be formation takes place. Next, acidity. Oxytenes are the next one is oxytenes. Oxytenes is the saturated four-membered nitrogen compound, nitrogen saturated four-membered oxygen containing heterocyclic compounds. Saturated four-membered oxygen containing heterocyclic compounds are oxytenes. Now, synthesis of this oxytene is first one is Paterno-Buch reaction, photochemical reaction. Paterno-Bucci reaction. Paterno-Buch reaction when carbonyl compounds reacting with alkenes, carbonyl compounds reacting with alkenes in presence of photochemical condition, then undergo 2 pi plus 2 pi cycloaddition reaction. 2 pi plus 2 pi cycloaddition reaction. The product will be is the oxytene is the product is formation takes place. Oxytene is the product will be formation takes place. This is one of the methods. Second method is intramolecular cyclation reaction. Next one is intramolecular cyclation reaction. Intramolecular cyclation reaction. When alpha, beta, gamma hydroxy, gamma halo alcohols, gamma halo alcohols, and gamma halo alcohols when reacting with the base. When reacting with base subtract the proton from here. It is attack at halogen position. Halogen is elimination takes place. Then the product is oxytene will be formation takes place. Gamma halo alcohols. When gamma halo alcohols undergo involved in the synthesis of oxytenes. Next one is reactions. Next one is reactions. When oxytocin is strong Lewis base than oxygenates, ring strain is less than oxytocin. We have four-member ring. In generally, four-member rings are somewhat stable than the three-member ring. So therefore, these are somewhat stable than the oxytocin, somewhat stable than oxygenates. Next one is reaction. That is acid catalyzed ring opening reaction. Acid catalyzed ring opening reaction. acid catalase ring open reaction when oxiranes reacting with HCl. So lone pair of electron oxygen into proton, then oxygen getting positive charge, ring opening and produces alpha, beta, gamma halo alcohols. Gamma halo alcohols are the product will be formation takes place. This is one of the example for acid catalyzed ring opening reactions. Next one is base catalyzed ring opening reactions. Base catalyzed ring opening reaction when base catalyzed ring opening reaction base catalyzed ring opening reaction when oxiranes reacting with base I am taken methylamine. Methylamine is a base catalyzed ring opening reaction. Lone pair of electrons and oxygen, nitrogen in amines donated to oxygen attached to carbon. The sigma bond shift between oxygen and carbon shift into oxygen side. Then oxygen getting negative charge and this carbon attached to NH2 CH3. Here positive charge is there. Then elimination of proton, that a proton attack at here. Then the product is base catalyzed ring opening reaction. Next, thermal reaction, thermolysis or thermal reaction, thermolysis or thermal reaction, thermolysis thermal reaction in presence of uh, 50 to 300 degrees Celsius, 250 to 300 degrees Celsius. The ring will be open takes place. The ring will be open takes place. Then the product is EH phenyl trans compound will be formation takes place and C2 formaldehyde will be formation takes place. This is a reverse of pattern-Butch reaction. This is a reverse of pattern-Butch reaction. Next one is photochemical reaction. Thermal reaction. This is 620 photolysis or photochemical reaction. Photochemical reaction when in presence of photochemical condition, the ring undergo rearrangement takes place, then forms phenyl methyl C double bond will be takes place. So here the reaction in presence of photochemical condition, the one of pi bond between ring and dimethyl carbon under homolytical cleavage then forms biradicals. Biradicals will be formation takes place. These biradicals here the sigma bond shift cleavage takes place. Here that sigma bond will be breakage takes place. Then here after sigma bond, so here after cleavaging of here, after breakaging here, then here radical. These two radical bond will be formation takes place. Here double bond and here radical. The bond between these two radicals will be takes place. So 1, 2, 3, 4. Phenyl, methyl. Here adjacent oxygen, same product will be formation takes place. So the photochemical reactions of uh, photochemical reaction of oxydates. Next one is titans. titans. Here, titans are the saturated four-membered or sulfur-containing heterocyclic compound. Saturated four-membered sulfur-containing heterocyclic compounds are called titans. Synthesis of this compound is when 1 comma 4 1 comma 3 dihalo 1 comma 3 dihalo compounds when 1 comma 3 dihalo compounds when these 1 comma 3 dihalo compounds reacting with Na2S reacting with Na2S. So Na2S loss of 2 moles of NX NaX loss of 2 moles of NaX then forms sulfur. Here this is the titans will be product will be formation takes place. Next one is from 1,3 diols from 1,3 diols from 1,3 diols from 1,3 diols when 1,3 diols when 1,3 diols reacting with SOCl2 loss of 2 moles of HCl then forms a cyclic ester will be formation takes place. Cyclic ester will be formation takes place. This cyclic ester previous case like this when reacting with NCS minus. So it is attack at it will be attack at sulfur atom here. Sulfur atom attack it up, they're shifting towards oxygen side. Then the product is oxygen atom. Okay. It is involved in loss of carbon dioxide. It is involved in loss of carbon dioxide. The product is O minus S C to bond N. The bond shifting towards carbon of cyano. The pi bond shifting to nitrogen side. Then the product is sulfur, oxygen, N. Okay. Now it is undergo again cleavaging like when attacking it here reverse is when it is attacking here when the product is sulfur, oxygen, N minus. It is again coming back to sulfur atom. Then the product is S minus OCM. It is attacking at here. The bond will be lost and the product is 1, 2, 3, 4-membered ring will be formation takes place. Then product is 4-membered ring will be formation takes place. So this is the product will be formation takes place. Elimination of CNO minus NCNO minus will be elimination takes place. So next one is reactions. The titane ring system is less reactive than thyrenes due to the less electronic strain. Therefore, electrophilic reaction. Next, opening of the reaction ring. Opening of ring system. Opening of ring system. So in opening of ring system, in presence of acid catalyzed and basic catalyzed, same cases. In presence of acid catalyzed, presence of acid catalyst, in presence of base catalyst. Previous case like this only. In presence of base catalyst. Acid catalyst, this is base catalyst. Next, formation of quaternary salt. Formation of quaternary salt. formation of quaternary solids. Quaternary salt. Formation of quaternary salt. When titans reacting with methyl iodide, then forms attacking it here. Sulfur having lone pair of electrons, donate to methyl group and elimination of I minus, then forms positive charge on sulfur. Okay, this is one of the quaternary salts. Next one is oxidation. Reacting with hydrogen peroxide, sulfur is more reactive towards oxygen atoms, then forms sulfones. Is the product will be formation takes place. Next one, photochemical reaction. Photochemical reaction, when this compound same in terms of photochemical condition, then trans alkenes and S double bond CH2 is the product will be formation takes place. Next, aziridines. Last compound is aziridines. Okay, aziridines is the saturated four-membered nitrogen containing heterocyclic compound. Saturated four-membered nitrogen containing heterocyclic compounds are aziridines. So this of these aziridines from alpha beta gamma haloamines. Gamma haloamines reacting with base in presence of base, elimination of HBr, then forms aziridine is the product will be formation takes place. From gamma lactones, first method. Second method from gamma lactones. When gamma lactones reacting with bromine in presence of PBr3, Br. Okay, now it is reacting with ethanol, HBr, ethanol and HBr. So ethanol and HBr, alkylation takes place here, bromination takes place here. Alkylation takes place on ester place and bromination on alpha position of ester. This next one is it is reacting with reacting with amines, NH2 reacting with amines. It is involves in displacement reaction. It involves in displacement reaction. It is involved displacement reaction. Then Br methyl and NH like this. Now it is involves in loss of alkyl groups like this. Involves loss of Br. Then the product is NHCO ester. This is the product will be formation takes place. Next one is reactions. Azidine is a strong base than aziridines. Azidine is a strong base than aridines. So quaternation takes place. Ring opening reaction. Ring opening reaction. 2 moles of HCl. It is involves chlorine like this. Next, reacting with nitrogen atom. Reactions of nitrogen atom. When we take here, when reacting with the base followed by carbon disulfide, C double bond is SH. It is reacting with the acyl chloride in presence of base. Acylation takes place on nitrogen atom. So like this will be takes place, and quaternization will take 2 moles of methyl iodide, 2 moles of methyl iodide. Quaternization will be takes place CH3 positive charge. Quaternary ammonia will be formation takes place. So uh, this is a 3 and 4 membered ring heterocyclic compounds. We are discussing that compounds are oxidines, thyrines, aziridines, oxetanes, titans, aziridines. These compounds are we are discussed. Okay. So thank you. Next class will be continue next week.
బస్సు వెళ్ళిపోయింది అంటుంది.